All right, guys, on number 1, it says determine whether triangle ABE is similar to triangle DCE. Okay? So here's triangle ABE. We basically want to know if it has the same shape, just not necessarily the same size as triangle DCE. All right, so because they're asking about similar, remember that we have 3 methods. We have angle, angle, similarity, side, 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 similarity, or side, angle, side, similarity. So looking at this picture, both triangles have all 3 pairs of sides. So it makes sense to me to just go with side, side, side similarity. All right. So I'm going to go ahead and highlight my small sides. In the blue triangle, my small side is 6. In the green triangle, my small side is 7.5. Okay. In my blue triangle, my medium side is 10. In the green triangle, my medium side is 12.5. Okay. And in my blue triangle, my large side is 14. And in my green triangle, my large side is 17.5. And now I'm just going to go ahead and set up my ratios. Okay. Remember, it does not matter what triangle you start with. I'm going to start with the blue ones. Okay. So its sides will all be on top. All right. So I'm going to start with the small is 6 divided by my small in the bigger triangle, 7.5. Medium side of 10 divided by my medium side of 12.5. My large side of 14 divided by my large side of 17.5. Okay, I'm going to grab my calculator. I'm going to go ahead and type them in. So 6 divided by 7.5 okay, is a decimal of 0.8, or you can math frac, it doesn't matter. 10 divided by 12.5 is a decimal of 0.8. And 14 divided by 17.5 is a same decimal of 0.8. And since all the ratios are equal of the corresponding sides, these 2 triangles are similar by side, side, side similarity. Okay. Number 2, determine whether triangle ABC is similar to triangle EDC. So my blue triangle, triangle ABC. All right, so this one's got a similar triangle possibly inside of it, so a little bit strange. Okay, so maybe I'll just highlight them instead of shading them in. EDC is here. Okay. All right. Let's see. In my blue triangle, maybe I'm going to separate them, I think. Make things a little bit easier. Sometimes when the picture's too complicated, it makes my brain hurt to think. All right, so in this triangle, this will be my A, this will be my B, this will be my C. And it looks like BC, from B to C, has 2 parts on it, 3 and 5, which make a total of 8. On AC, it's got 2 parts also, 6 and 4, which make a total of 10. Okay. If you want, you can draw your little triangle again too, so that it's not inside that picture. I don't know if that'll help you. I know that it helps me. It's just that sometimes we're too lazy to do it, even though we know it helps. Okay. All right, so here we go, guys. In this one, it doesn't look like we're going to go with 3 pairs of sides because we're missing a side in each triangle. And so I think we're going to go ahead with side, angle, side. All right, and before I compare the sides, I have to find an angle between the sides, and it's angle C. Angle C is actually the same angle in the blue triangle as it is in the green triangle, because that's where they were like overlapping inside of each other. So angle C would be what we call the reflexive angle. It's a shared angle, if you remember that, all right, from when we were talking about shared sides before. This is actually a shared angle. Okay. All right, so now that I found my angle, it has the possibility of being side, angle, side similarity, as long as I compare my numbers. All right, so I'm going to go ahead and highlight them so they're easier to compare. 8 is my small side here, and 4 is my small side here, so be careful with that. 10 is my large side here, and 5 is my large side here. Okay. All right, we'll go ahead and compare them. I'm going to start with my blue triangle again first, and so I'm going to take his small side of 8 and divide by the small side here, which is 4. And we're going to see if that's equal to the large side divided by the large side. All right, 8 divided by 4 is 2, and 10 divided by 5 is also 2. And so these 2 triangles are similar by side, angle, side similarity. All right. I just wanted to point out something in the first one. These are tip-to-tip triangles. Remember, vertical angles are congruent. So if you wanted to, you could have just compared the 6 and the 7.5 and the 10 and the 12.5. and said that the angle in the middle here is a vertical angle, and that vertical angles are congruent. And then you could have also said that these triangles were similar by side angle side similarity, because that vertical angle would have been between those sides. All right. And again, over here, we should mention that these two angles are congruent because it's reflexive or shared. Okay. All right, guys, let's go ahead and try some more. See what else they have. Number 3, it says using the information given below, which set of triangles cannot be proven similar? Cannot. So remember our theorems for similar are angle similarity, side similarity, or a combo of side angle side similarity. So let's take a look at our first picture. Okay. And in our first picture here, which is hard to see because let's see if I can make this a little bit smaller. Oh, there we go. Okay. So it looks like we have 12 and 4 and 3 and 9. So if we highlight small side and small side, and my 4 will go and get highlighted with my large side of 12. That's underneath my little box here. Okay. So it won't let me do it, but that's okay. All right. I think you guys can see it. And so we have, we can start with the 9 divided by the 3. And we're going to see if that's equal to the 12 divided by the 4. All right. Notice that we have the angle in between the two sides that we're comparing in the same congruent angle. Right angles are congruent. They're both 90 in the other triangle. And so if we take 9 and we divide it by 3, we get 3. And 12 divided by 4 is also 3. And so these two triangles are similar by side angle side similarity, but they're looking for which ones aren't. So we're going to go to the next pair. In number 2, these two triangles are actually congruent. Okay, but if triangles are congruent, they are also similar. Because remember, we say they have to have the same shape, just not necessarily the same size. All right. But what they're saying is that that pair of sides matches, and that pair of sides matches, and that angle in between them matches. And so these triangles are actually congruent by side angle side. Okay. And so if they're congruent by side angle side, they're also similar by side angle side similarity. But we're looking for which ones are not similar. All right. In number 3, it looks to me that this doesn't follow any one of our theorems. It's very close to being side angle side similarity. However, if they're giving me this side and this side, then instead of that angle, I should have gotten that angle if this one had a chance. And so this one in number 3 is not and cannot be proven similar. Angle is not between, or what they call included, the sides. Okay, it's got to be between those sides, and this one's not. All right. In number 4, that's what we call angle. So that angle matches that angle, and this angle matches this angle, and this is angle similarity. Okay. So we're going to go with choice 3. All right. Number 4, it says triangles RST and XYZ are drawn below, and it says that RS is 6. ST is 14. XY is 9. And that YZ is 23. Oh, one more piece. Angle S is congruent to angle Y, which is perfect because that's the angle in between the sides. All right. So we're going to go ahead and try for side angle side similarity. We're going to go ahead and highlight our small sides. Here's the 6 and here the 9 and our large sides. And now we can go ahead and compare. All right. So I'm going to take 6, and divide it by 9 and see if that's equal to 14 divided by 23. All right. 6 divided by 9 is 2/3. And 14 divided by 23 is 14 over 23. That doesn't reduce to 2/3. And so in this case, you can go ahead and see that these ratios are not equal, and therefore triangles are not similar. Okay. And so they said, is triangle RST similar to triangle XYZ? And we're going to say no. Okay. And we have justification right here, okay, that they are not equal ratios. And therefore, they are not similar triangles. All right, number 5, last one. It says in the diagram below, triangle ABC is similar to triangle DEF. And they told us that AB is 6 and that AC is 8, and they want to know which statement will justify similarity by side angle side. All right, so they're saying in choice 1 that DE is 9, that DF is 12, and that angle A is equal to angle D. All right, so there's the angle part about the side angle side. Now we just have to see if those ratios work out. All right, so 6 is the small one, 9 is the small one, 8 is the large, 12 is the large. Let's see if this ratio works out. Okay, so 6 over 9 is 2/3. 8 over 12 is also 2/3. And so I think we hit the first one on the head there. That one would make them similar by side angle side. Okay, let's just take a look at what the other ones and what happens with those ones to see what it looks like when it doesn't work out. Okay, I'm going to keep angle A and angle D marked because in choice 2 they have the same angles given to us, except they made DE 8 and DEF 10. All right, so I would still take my small side from the first triangle of 6 and compare it to 8, the small side from the bigger triangle. And then I go back to the small triangle and grab the large side, and then go back to the big triangle, grab the large side. All right, what happens here is that this still gives me 2/3. Okay. Oh, no, it doesn't give me 2/3 because that's not a 9 anymore. 6 divided by 8, what does that reduce to? Both numbers are divisible by 2. So that would be 3/4. And 8/10, both numbers are divisible by 2 as well. So that would give me what? 4/5. And those are not equal. All right, so that's why choice 2 does not work out. All right, let's take a look at choice 3. It's not letting me erase. There we go. In choice 3, they tell us that DE is 36, that DF is 64, and that angle C is congruent to angle F. And right there, that can't even be side angle side similarity because the angle's not between. And you know what? In choice 4, they give you the same pair of angles, and so those don't even have a chance. And so choice 1 is the one we're going to go ahead and stick with because that's the one where the angles between the sides and the sides were in equal ratios. Okay? All right, guys. Hopefully that helps, and I will see you guys on the next day of notes. Thanks.